Introducing the fundamental interrelationships model.
Representing Newton's three laws of motion.
First law. An object will remain in its current state with balanced external force. The upper curved line represents the driving force. The lower line represents the resistance. Without unbalanced external force, the object will remain in its current state, either at rest or moving at a constant speed. This is represented as the horizontal straight red line in the model. In a Cartesian coordinate system, this horizontal line is consistent with the first law of Newton's motion. Second law. When the forces become unbalanced, an object will change its direction and speed. In this model, it is expressed as an ascending straight line. This ascending straight line in a Cartesian coordinate system represents F equals ma, which is Newton's second law of motion. The third law states that for every action in nature, there is an equal and opposite reaction. The first law of thermodynamics. In this model, different colors represent different forms of energy. The identical size of these units represent that the amount of energy is invariant after transforming from one form to another. This is consistent with the law of conservation of energy, the first law of thermodynamics. The second law of thermodynamics. The second law of thermodynamics states that the total entropy of an isolated system can never decrease over time. This model represents the level of disorder increase over time. The third law of thermodynamics. As its temperature approaches absolute zero, entropy of a system approaches a constant value. The zeroth law of thermodynamics. If two thermodynamic systems, each are in thermal equilibrium with the third one, then they are in thermal equilibrium with each other. In this model, A is symmetrical to A prime is symmetrical to E prime, A is symmetrical to E prime. These are consistent with the zeroth law of thermodynamics. Einstein's special relativity. Einstein's theory of special relativity states that when space expands, time contracts. The Heisenberg uncertainty principle states that the more precisely a particle's position is measured, the less precisely its momentum can be known, and vice versa. For more detailed information, you can download a copy of the book Behind Civilization from Amazon.com or search with Google on the internet.